All right, Conductivity of Substances Lab. Here's what we're going to do. I'm going to talk about how to set this up. I'm going to talk about some of the videos that are on here and kind of show those videos and talk about them. They're both pretty short, so they should fit inside this one. Let's talk about trying to do this at home. If you want, these are the materials that you're going to need. You're going to be able to do some of the lab at home with materials you might have, which would be pretty cool. But I will say, don't worry if you don't have it. All of the data is filled out at the bottom of the page, and it's worth looking at even if you do the experiment at home, because there are going to be some things that you can't do at home. Go ahead and answer these pre-lab questions. Question number 1, do you think that water conducts electricity? And question number 2, do you think the bath water in Madison's tub was pure water? And if not, what else could have been in the bath water? So think about that, and we're going to talk about those in a minute. So I'll give you 5 seconds here, and then I will move on down. Okay, so evidence of conductivity. First question we have, does pure water conduct electricity? So let's take a look at this video right here. It's a pretty short video. It's just a couple minutes long, so I will watch it with you here. I'll also link this video separately. So what we've got here is we've got a battery, or not a battery, but a light hooked up to a power source and then 2 wires, right? And when they connected the wires, what did that do? It completed the circuit, which allows the electricity to flow. So this is going back to what we talked about with electricity. When it has a complete circuit, the electricity can flow. So now what they're going to do is they're going to connect each of the wires to these little clips here. And they're going to put the clips into this tub. And what it's going to test is, does electricity flow between these 2 clips? If it flows between these 2 clips, then they'll have completed the circuit, right? So think about what evidence you have of that. Right now, there's only air inside this container. They haven't added anything. First thing they're going to add is some water. All right, so as they've got this here, think about this. Does this meet up with what you were expecting to happen or not? Next thing they've got here is some salt. So they're going to add some salt into the water. And think about what we see. What does that mean? What's different about the salt in the water and the water without the salt? So think about that. That's really all I've got from this video. So I am going to go ahead and pause that and switch on back. So thinking about these questions we have underneath this, does pure water conduct electricity? Explain your answer. How do you know that? Does water with salt, which is sodium chloride, conduct electricity? Explain your answer. What evidence is used in the video to show that conductivity is happening? How do we know when electricity is flowing through the substance? So conductivity is the ability for electricity to flow through substance. Hi, Katie, do you want to come up? Nope. Okay. All right. So other evidence of conducting. The cat who wants to come up. Kitty, you like being part of the videos, don't you? Yes, Minnie. All right. So if you want to test conductivity at home, you probably don't have a setup like we just saw in that video. You don't have a light. You don't have wires that conduct well enough to make that happen. You could maybe try figuring something out with that, but we can also think of other ways to do it. There is another video here I'll show you really quickly where you can think about one thing that's happening, but we're also going to discuss a third thing that happens. Okay, so looking at this video, I will say this is a video of stuff happening over a very, very long period of time. So this video is sped up to some extent. You'll notice right here, you can kind of see, oh, look, that's, pretty obviously time lapse. But we do see some stuff happening here? We see an electrochemical reaction happening. So that's one way we can look. We can look to see if there's bubbles being produced in the water. That's a great way to figure out if there is conductivity happening in the liquid. So that's one thing we can do. Another thing, that's what we can come back here. What evidence shows conductivity is happening in this video? It kind of just says that. And does the copper 2 chloride, does that conduct electricity when it's dissolved in water? So what do you think? Here's where we're thinking about, I'll come back to this in a second. If you go to test on your own, the other thing you can look for, remember when we saw that wires were part of a circuit that conducted electricity, there was some resistance in that circuit, and resistance produces heat. So that's the other thing you can be looking for if you test this on your own at home. You can look to see, does the circuit produce heat? Do the wires get hot? All right. So here's where we're at. Preparing for the lab. Maybe think about rewriting these definitions. So these are 3 important things. If something dissolves, it becomes completely incorporated into a liquid. It completely breaks down and spreads out within a liquid. So think about writing that in your own way. Conductivity, we've talked about this before, the ability of a substance to pass charged particles through it. So does it conduct electricity, right? Solubility, soluble, property of a substance that means it is able to dissolve. So those are 3 things that we're really thinking about here. I want you to fill in your predictions for each substance you will test. Will it conduct as a solid? Will it be able to dissolve? And will it conduct electricity through water once it's in the water? So you have these 6 things right here: aluminum foil, sugar, sodium chloride, which is table salt, silicon dioxide, which is sand, paraffin wax, and copper. So copper, you could just use a penny if you wanted to, because it's copper plated. That would work for that. Aluminum foil you might have, sugar you might have, salt you might have, sand you may or may not have. You can go, well, I would advise against grabbing it from outside because it's not likely to be pure sand, but maybe you've got some sand lying around. That's something you can try. And then paraffin, maybe you've got some paraffin wax, maybe you don't. Don't worry about it if you're testing it on your own. So you want to do a couple of things. First off, you want to test each of them dry, right? So you're going to tape the paper clips to each end of the battery, and then touch the ends of paper clips together. Remember, that'll make them get warm. That completes the short circuit. So we're going to test our other substances. We're going to test all of the solid substances. Wait to see if they get warm, they conduct. You would mark yes under conduct when not dissolved. So then you're going to get glasses of water. You're going to put a little bit into the water, put them into the water, put all the stuff into the water, see if it dissolves. Does it incorporate into the water? Does it kind of disappear? All right. And then you're going to test to see if the water now conducts. So you're going to take your paper clips that are attached to the battery and put them in. And so here's where we're at. We've looked at some of these already. Interesting. I didn't think we had sand on here. That's why I was confused by that. So copper sulfate, very similar to the copper chloride video we saw. It does not conduct electricity when it's not dissolved. It is able to dissolve, however, and it does make the water conduct. Water we saw does not conduct. It doesn't really matter if it's able to dissolve in water. It doesn't make the water conduct. No, I mean, we can't really answer those. Ethanol is a substance that is on this list. It does not conduct when dissolved, or does not conduct when not dissolved. It does dissolve, but then it does not make the water conduct. calcium chloride does not conduct by itself. It was able to dissolve, and it does make the water conduct. Silicon dioxide, the sand, does not conduct, does not dissolve, and so does not make the water conduct. So then thinking about these last 5 substances here. Finally, we're going to look at the analysis of the data. A lot of this you can do before you fill in the data. If you were not able to get the data yourself, scroll on down to the bottom and get the data from the data table down there. Okay. I would like you to put it up here, though, just so you can look at it in both places. Think about which substances are made of only metals. Remember, metals are on the left side of the periodic table, so there are some things specifically that we talked about, like sodium, which are metals, even though you often don't think of them as metals. Remember again that salt is not just sodium. Salt is sodium and chloride together. So is that something that's going to fall into the only metal atoms category, the only non-metal atoms category, or the metal and non-metal atoms category? So think about looking at a periodic table and determining whether something is a metal or not. If something is a metalloid, I will tell you this, like silicon, for example. Let's go ahead and count that as a non-metal. And then we're going to organize our substances into groups. Which ones were able to dissolve? List all of them. And then under that, for the ones that were able to dissolve, which ones conducted electricity and which ones did not? Which substances were not able to dissolve? List them all. And then come on down. Which ones in the did not dissolve group? Which ones of those conducted electricity and which ones did not? And then you're going to write them in groups. Which ones were soluble and conduct? Which ones were soluble but do not conduct? And when we talk about conduct, I mean either by itself or when it's dissolved. I want you to look for patterns in the data. What do you notice about that? And then answer these questions. If something that will make the water conduct, is it made of only metal, metal and non-metal, or only non-metal? Substances that will conduct but do not dissolve are made of metal atoms only, metal and non-metal atoms, or non-metal atoms only. Substances that may be soluble but will not conduct either as a solid or when dissolved are made of what? All right. And then to put it all together, predict whether isopropanol C3H2O will conduct electricity and explain why you think that. Finally, it's dangerous to take a bath with a blow dryer, which hopefully you all have heard before. Don't be using a blow dryer when you're in the bath. What must also be true about the water in the bathtub? Think about that and explain your answer. And then think about this question. Bathtubs are hot, we sweat, in our sweat we have salt. Based on that, what do you know about salt, NaCl? All right, that's about all I've got for this one. This was a pretty long one. Hopefully it was helpful. Good luck getting through this. As I said before, you're probably now at this point where you're like, oh, cool, I can explain why she was electrocuted in the bath. And to some extent you can. You can now explain something about it, but I want you to keep in mind that what we're going to work on the rest of this unit is explaining how does that happen? What happens to the atoms to make it conduct electricity? All right, that's all I've got, so I'll get started on the next video here in a minute.